you to check that out. I have been involved with the whole enterprise Java ecosystem for quite a long time. I wrote a book a long time ago, like 2004, about Java server faces. And I've been involved with JSF and portlets and CDI and JSP, all those technologies for a long time as well. And I speak at lots of conferences. So that's my story. I'd like to get a handle from the audience about you guys. What I'm curious about, I've got sort of two main questions for you. First is, have you worked with virtual threads at all yet? And the second question is, what framework, what framework do you use for web services these days? Like, do you use Spring Boot, or do you use CartEE? Do you use MicroProfile? Do you use Quarkus? Do you use, what do you use? So if you could put that in the chat, I appreciate it. That'll just give me an idea of sort of the level of interest or the topics that you might be interested in talking about. All right, I'm looking in the chat. Hey guys, don't be shy. Okay, so I see, okay, now I'm getting some responses. Okay, I see Spring Boot, Micronaut. All right. CartEE10 plus Pyara. Okay, good. Someone tried virtual threads for web scraping. That makes a lot of sense, definitely. I've been thinking about doing some web scraping with AI tools, just as an experiment, a different way of doing web scraping. So Open Liberty, okay, excellent. Quarkus, which is a microprofile implementation. Okay. All right, so that gives me an idea, which is great. Thank you very much. So I've, as I've been in the industry over like 20 something years. I think I stopped counting once I got past 20. And I now have I take a very historical perspective on things. And I'm starting to bring this to my talks. So I want to start out with a journey through the world of Java threads. And what I want to do is start out with something from the olden days, as my daughter would say, back in the 1990s, which she considers a long time ago, the 1900s, So in JDK 1.1 to 1.2, there was something in Java called the green threads, or called green threads. And essentially what this is, or was, I should say, was the ability for the JVM to support only threaded model available, but it was the ability for the JVM to support multiple threads for multiple virtual threads, or green threads as they call them, for one single operating system or platform thread. And that's what we call M-to-1 scheduling. So for every single platform thread, there could be X number or M number of green threads. And this was one of the ways they tried to achieve some performance gains in the early versions of the JDK. Now you have to remember, back then we didn't have lots of cores, right? So your machine may only have a couple cores or a few cores, so we weren't talking about lots of different threads being available to the JVM to begin with. But the idea was that you could actually achieve some better performance by having multiple threads, virtual threads or green threads, running on top of a single platform thread. And this was actually created by the green team at Sun Microsystems, which was the original creator of Java, of course. And they basically, the threads would use sort of a cooperative concurrency feature or mechanism to achieve sort of parallel performance gains like operating system threads. And the main drawback, though, is that if you had a green thread that blocked, it would block all of the other green threads and the platform thread. So basically, you could achieve some parallelism, right? But whenever you had an IO operation, meaning something on the network, something in a database, something in a disk, whatever, you would essentially block a whole lot of threads. And so that was the story. And if you're curious about it, you can check out Wikipedia. It has an okay entry on it. But this was taken out by JDK 1.3 because they determined that the platform threads were actually faster. So that's when we ended up with the model that we have today, which is every Java thread maps to an operating system thread. So it's a one-to-one model, very simple to understand. You create a Java thread, you're creating an operating system thread. And as we got more powerful systems, this made a lot of sense, right? Because we had more threads available to work with, et cetera, et cetera. So then we have one-to-one scheduling, right? One platform thread, one Java thread. Very straightforward. All right. So one of the sort of, I guess you could say, effects of the original thread model in Java, or not the original, but the main thread model in Java since 1.3, is the problem of blocking, right? So this picture here is American football. For those who are not American football fans, basically what's happening here is you have the receiver, okay? And you're not seeing a cursor here, but on the left-hand side, there's a receiver. I'm sorry, the left-hand side is the quarterback. He's just trying to throw it to a receiver, excuse me. So the quarterback is back here on the left-hand side, and he's trying to throw it to somebody who you can't see on the screen. And in front of him are people who are blocking the defense from getting to the quarterback, because once they get the quarterback, of course, he gets sacked and the play's over, right? So a lot of blocking happens in football. And this is sort of what happens with our applications as well, right? You can think of the need to block as basically anything, basically anytime there's some sort of I/O operation, you have to block, right? So we initially had the Surfit API as a way to write web applications in Java, and that basically is a blocking API. And basically what it means is you have every single request that comes in is a map to an actual Java thread, which maps to a platform thread. And then if that thread blocks on something, it blocks. That's what happens, right? And that's the way it works. And that works fine for a lot of cases, and it worked fine for years and years. And this is also the way the Apache web server was written as well. So single incoming request maps to a single thread. It's also very easy to understand the way it works. And this was really just fine. However, as time went on, our systems got a little bit bigger, right? Because the internet grew and grew. We had some massive websites that needed to be able to scale on a massive level. And the ability to handle, or the drawback of handling one thread per request became obvious because you ended up having scalability issues, right? So in 2004, Nginx came out. And Nginx, the main innovation there is that it uses an event loop. And basically, each request that comes in is an event, and it can then be handled asynchronously. And then Nginx can go handle another request, right? And the idea was that Nginx was supposed to solve the C10K problem, which is basically the ability to handle 10,000 concurrent requests. And that's something Apache could not do at the time. So Nginx was able to do this. And those of us who have been around a while noticed that, for many, many years, Apache was the dominant web server. It was just like, 80-something% of the market share. And Nginx pretty heavily ate at that market share over the years by having this really good support for high volume transactions. So that's the deal. And one of the things to point out here is that this ability to handle more requests, it doesn't really mean the application is faster. It just means that it's more scalable and more predictable in the way it performs, right? So it doesn't mean that each request is actually handled faster, as long as you don't hit the maximum level of scalability of the particular configuration you have. But it means that you can scale better. So Nginx came out in 2004. Netty, which is Java-based, came out in 2004 as well. Same idea. All these use a similar model of taking in events and then dispatching them to asynchronous processors. Node.js came out in 2009, and this is the reason that Node is so performant. It's because it uses the same model. Akka, which all of the Scala aficionados know, came out in 2010. And Vertex, which is built on Netty but at a higher level, came out in 2011. So all of these came out using this asynchronous model to basically handle higher scalability, right? And this, of course, caught on. So in Java EE7, which came out in 2013, this was actually added to the Java EE specs. So Server 3.1 has the ability to support asynchronous requests, and so does JAX-RS, which is now Jakarta REST as well. So they both have the ability to handle asynchronous requests as well. So kind of caught on, started out, in a lot of servers, and then made its way into Jakarta EE or Java EE at the time. And then in 2014, we had the Reactive Manifesto. So this is basically sort of an encapsulation of all the different sort of reactive thoughts and development that's going on at the time. And the idea was that by having a message-driven architecture, which you can also consider event-driven, your systems can be elastic, resilient, and more responsive and extensible, maintainable, etc. If you want to read more about this, you can go to the reactivemanifesto.com. But basically, the idea is you want your systems to perform to have rapid and consistent response times, and be reliable in terms of what they provide. You also want to make sure they have good error handling, don't fail without, basically that they can still run when there's failures going on, which is where the whole resilient idea comes on. Elastic means the ability for it to grow and shrink in terms of the amount of capacity that it needs to fulfill requests for varying workloads. And of course, message-driven is just that, message-driven or event-driven. And of course, what sort of underlies all this is this whole non-blocking idea, right? That when a message is sent, it's handled, but in an asynchronous manner. So the Reactive Manifesto came out in 2014, which is 10 years ago now. And of course, around the same time, we had a whole bunch of different APIs for doing this sort of work. So the biggest one, of course, is ReactiveX, which has extensions for .NET, JavaScript, Java, and a whole bunch of other languages. And then, of course, there's Spring Project Reactor, which is used in Spring Boot. There's Reactive Streams, which is actually part of Java, the JDK. I'm sorry. There's Reactive Streams interface or standards, and then there's the actual Java 9 Reactive Streams, which is the flow interface. So Java 9 has that built in as well. Small Wire Mutiny, which is from JBoss, supports this as well. And so these are sort of the different APIs that you come in contact with when you're writing reactive code. So I just wanted to talk about a few reactive concepts. This of course, this talk is not about reactive, but what I want to do is sort of give a concept of what reactive was trying to solve and how virtual threads fit into all that. So reactive basically has the idea that you have an incoming request, right? We'll say you're handling a HTTP request or whatever in the context of a service, let's say. You work with different data types, and these data types are pretty much asynchronous. So you have an observer and an observable. And an observer is basically something that subscribes to some events. An observable, of course, is something that emits events. Spring Reactor and Small Wire Mutiny, they are called Flux and Multi. Those are the names for those types, essentially. And then you have different operators. And these are operators we're very familiar with from the Java Streams API, right? So you can do map, flat map, buffer, filter, take, skip, join, debalance, etc. So basically you have a stream of events, and then you can work on those events and transform them or operate on them. There's also the idea of having an observer and observable that's just of one item. Or I'm sorry, an observable of one item as opposed to multi. And that's called mono or uni in Spring Reactor and Small Wire Mutiny. It's also a subject. And a subject is basically something that can do both. It can be an observer and an observable. So you can get some extra features out of that. And then there's, of course, a scheduler behind all this, because the scheduler has to manage, coordinating all the events that are happening. So those are all of the different sort of operators and things that are available in reactive programming. And you find any reactive code, you'll just find a lot of these different, basically a lot of observers and observables and operators and things like that, which basically looks like what we do with streams. So when it comes to reactive services, what's happened over the years is that if you take a look at all this, we had the reactive sort of web servers, essentially, for taking in a web request like Netty and Nginx, etc. Right? Then we had the manifesto, and then we had APIs for building reactive constructs. Okay. But then, of course, when you're writing a microservice, you're using some microservice framework, right? So then you want your microservice framework to use those reactive APIs so that you can write reactive microservices. So Quarkus, of course, has support via SmallWire Mutiny, Spring Boot. You can do it with Webflux, and Vertex you can just use directly as well. And Micronaut has support as well. So all these different frameworks have a way for you to write some reactive endpoints if you want to. And this, I think, is a very useful graphic. This is actually from the Spring website. So on the left-hand side, we have the reactive stack, and on the right-hand side, we have the Throughput stack. And what's interesting is if you look at what we have on the left, the container that you can use for reactive can either be Netty, which, as we saw, was built from the ground up for reactive development, or Server 3.1 or higher, because remember, Server 3.1 or higher, which is part of Jakarta EE, supports async as well. Or you could use just a pure server stack where everything, one request per thread model where things block, right? So then on the left-hand side, you notice you're using a completely different set of APIs. You're using Spring Security Reactive, Spring Webflux, of course, which is the core set of reactive APIs. And then you're using Spring Data reactive repositories. So for all the Spring Data stuff, you need a completely different set of interfaces to use. On the right-hand side, you see there's the normal servlet stack. So that uses all the APIs you're used to, like normal Spring Security, normal Spring MVC, normal Spring Data repositories. So this underscores a key point here, which is that the reactive approach kind of requires you to go to reactive all the way down. So it kind of changes your entire programming model across your application, with the exception, of course, core business logic and things like that. So here's an example of a reactive service with Spring Webflux. This is taken from one of their example applications. But you see we've got a normal Spring REST controller. Let me see if I can highlight this. There we go. No, it does not highlight. Let's see, is this highlighting on the screen? Yes, it is. Okay, good. Okay, and we have this here, though. This is reactive Redis operations here. Okay. So let me scroll down. If this does scroll down, oops, sorry. So you see we have this one method here, public flux coffee. So this is a flux, which is a set of events, a set of, not really events, but values coming back, right? And we call our Redis operator, which is up here. And we get the keys, and then we do a flat map, and then we do opt values, and then we do get. Okay, this is a very, very simple example. But essentially what's happening is this operator, of course, is going to be configured to work correctly with Redis, right? And this is going to perform reactive operations on what's coming back. And so this is going to come asynchronously back. So this is a very simple example, right? We can look at an example with Quarkus. Okay, and this is actually from that Speaker Tracks app, because we did use the Quarkus reactive APIs for that. This example is GraphQL. It doesn't have to be GraphQL. I'm just showing a different example, but it's the same idea regardless. And these are, and this is actually a microprofile GraphQL. So these are normal CVI injection points. And then here is a query that's responding. This is basically just responding to a request for data, right? And see, this is a uni. So this is a single item that's being returned. and it's returning a find method here that's going to go and grab our particular object back and return it back as a uni. Okay. And then here we've got some utility methods, so you're not really seeing a lot of the underlying code. And let me see if we have it. So I don't have it in this example. But essentially the main thing is that we're sort of changing all the types, right? It's like you can't just return an object back, you have to wrap it in something. And that something has to be reactive. So you basically have sort of just changed the perspective of the way that you write the code. And you've kind of added a lot of noise, because at the end of the day, you don't really care whether it's a uni or a multi or whatever. You just want to return a list of objects or a single object or things like that. So reactive is great if you need it, right? If you really need that level of scalability, and you're okay with the extra sort of cognitive load of working that way, which some people are very familiar with, some are not. And usually, if you're not familiar with it, it takes a little bit of thinking. You have to like sort of wrap your head around it first, and then once you get it, you're fine. But there are some problems, so nothing's perfect. So the first thing is what I just mentioned, is that the code is kind of hard to read, right? So I showed you some very simple examples. This is an example of some more of our code, and this is just for persisting data to a particular to the database, essentially. So if you notice on the right here, whoops, sorry about that. Let me see if I can scroll over to the right, which I can't seem to do. My apologies. All right. Oh, there we go. Okay. So we got the we're passing in context, we're passing in input, we're passing in a function. So things to happen before you persist, things to happen after you persist, etc. So it's just a nice little utility method for updating the database, right? But it doesn't look particularly easy to read, right? Because we're creating these session callbacks, right? And this is actually using the Hibernate Reactive API. So again, it's a completely different API for working with Hibernate. We're doing all this stuff here. We're doing this supplier, which is a uni, because we're only going to be doing one object. And we're chaining the pre-persist, the persist, and the post-persist, and replacing with the entity. And we're doing some stuff here, looking at the entity, and then we're returning the single value. So, this isn't that bad, but it doesn't look particularly easy to read, of course. And this is just one simple example, right? So the code is not very easy to read. And you think about, bringing in different developers. Now, of course, you can use AI tools to tell you what it does, but it's not the easiest to read code. The other problem is the stack traces are hard to read. And this is, in some ways, a bigger issue. So this is an exception in that same application. You see suppress, so it was a validation exception, right? And the message is fine, right? Requested entity does not exist. Please specify another ID. That's fine. But then when I want to know where it came from, so it came from this utility method here, right? But I want to know the root, the root location, right? So, and what you find is that you're not seeing where it is. So what I'm seeing is the stack trace that's actually happening, right? Which is all of the reactive stuff, right? And you're trying to find where your code is. And it's kind of hard to find your code in the noise, okay? And of course, the more operations you do, the harder this is, harder this becomes, okay? That's another problem, I should say. Now, some of the reactive APIs give you the ability to add more context, but it's extra work and you have to be specific and you may miss some cases. So it's not perfect, but you can do better than this if you want to. So that's sort of my quick overview of Reactive. And I will be honest, I've never been like a huge Reactive supporter. Because normally the projects I've been on never had I never worked at like Amazon where we had to manage millions and billions of requests or anything. So maybe hundreds or thousands of requests, but not billions or not millions. But when JDK virtual threads came out, I got very excited because I realized that, hey, now we have sort of an alternative to reactive, right? So maybe there's a way that we can get some of the same performance gains without having to change the entire programming stack, the entire set of APIs that we're using. So in 2023, JDK Project Loom virtual threads came out. This was in JDK 19, and of course they're available in 22 now, and 21 was when they became final. So, and virtual threads come from the Loom project. Okay, and the Loom project, this is the official name, is Fibers, Continuations, and Tail Calls for the JVM. That's the official name of the project. And virtual threads are just one part of it. And Fiber was the earlier name for lightweight thread. So you can think of that as just being virtual thread. A continuation or a coroutine is a sequence of instructions, like you would have in a thread, that can yield and be resumed at a later stage. And there's been different ways to do continuations for a while in different languages. There's actually been frameworks that have done on top of Java before. But now it's actually built into the actual JVM libraries. So every continuation has an entry point and a yield point. And the yield point is basically where it's suspended. And whenever the caller resumes a continuation, the control resumes to the last yield point. This is basically what the JVM is doing with your virtual thread. So basically, it's pausing it and then continuing it later on when necessary. And tail call operation optimizations isn't yet implemented, so that's the last thing that's part of this. And the idea is that's an optimization for whenever a recursive function calls itself as the last action. So it's basically a way for the JVM to optimize that operation. So another couple things here. Let's see. So of course we talked about virtual threads, which is the main thing, right? There's also structure concurrency, which is on the second preview in JDK 22. And the idea with structure concurrency is to basically simplify concurrent programming by providing an API to sort of group together operations within a single scope. Okay. And what's nice about this is it plays very nicely with scoped values, which is a way to store state for a particular set of operations within a thread, or it looks like it's within a thread, I should say. And this is sort of a replacement for thread local variables. So the idea that you can have scope. So think of scoped values as being scoped within a particular structure. So these are not actually final yet, but they will be soon. And all of these features work very well together. However, you can still use, of course, you can use any of these preview features now, but also you can use virtual threads today without these features if you want to. So the fruit of the Loom project, or the Loom project, was started in 2017, and the first preview shipped in JDK 19, which is the fall of 2022. So it's been out for a couple of years now. And of course, the final version came out in the fall of last year. And we talked about how green threads had M-to-1 scheduling, right? You could have M number of green threads that would map to a single platform thread. With virtual threads, it's better. You have M number of virtual threads that can map to N number of platform threads. And the idea is that you can actually have a whole lot of virtual threads. There's actually no technical limit. There's no way, there's no like, number that you set that's the maximum number that are created or anything. It basically happens dynamically. And the idea is that you can basically scale as much as you want, as long as you don't do a couple things, which you shouldn't do. So this is a picture of how it sort of works, and I will jump over here to a larger version of it. Okay, so over on the left, you have the JDK scheduler. So, on an operating system, the operating system just has its own scheduler for threads. Now that we have virtual threads, JDK has to do scheduling of the virtual threads. And what it does is it basically whenever it needs to create a virtual thread, it creates it. And then when there is a platform thread available, it will attach it to a platform thread. And a platform thread, when it's attached to a virtual thread, we call it a carrier thread. Okay. So basically, you can have n number of virtual threads and m number of virtual threads and n number of platform threads at the top here. You guys can't, I don't think you can see my cursor. Let me see if you can see it. No, you can't see my cursor. My apologies. All right, so this is what's happening. So your virtual thread's being associated to a platform thread. And then I will again make this bigger. You need to worry about a couple things. So what you want to do is you don't want to block this virtual thread in a way that can pin it to the carrier thread. So if you do a normal IO operation, let's say you talk to the database, you do a network request, whatever, the scheduler says, okay, that's cool. I'm going to unpin you. I'm sorry, yeah. I'm going to not unpin you, but I'm going to uncarry you from a platform thread. And then it's going to attach another virtual thread to the platform thread while you're doing your IO work, right? However, if you do something that can block the operation, sort of like what happens with green threads, you can have a problem. And this only happens in a couple cases with virtual threads. It only happens if you have a synchronized block using the synchronized keyword that will pin, as we say, hence the pin image there, the virtual thread. And another problem is that if you call a native method or foreign function, that'll also pin the platform thread. So if you have code that does that, you can run into problems where you're actually maybe causing issues because you're going to have virtual threads that get pinned to the platform threads and will basically block them until they're done, which kind of defeats the whole point of virtual threads. So as long as you don't have those problems, you don't have synchronized blocks or foreign memory functions or native calls, you won't be pinning threads, which is nice. And then you get the ability to create as many of these as you want. They're very cheap to create. And then they'll just get assigned to platform threads when they're available. But of course, you want to make sure you don't have any other issues. So we talked about pinning, right? And that is synchronized blocks. The way to get around this is just to use the reentrant lock class instead. Native calls, you can't really get around that. Although I think some of the newer APIs may get around the issues with JNI, if I remember correctly. There's also a handy feature that you can use to help you find pin threads called trace pin threads. So if you use this as a JVM parameter, you actually get notified, you get output whenever there's a pin thread. So this is useful for helping you debug an application that you're trying to use with virtual threads. Another thing you have to do is make sure you don't do pooling, because there's no need to pool a virtual thread. The whole idea of pooling is that you have a limited number of resources and you want to basically ensure that you reuse them, because platform threads are expensive to create, right? Virtual threads are cheap to create. So you don't have to worry about creating lots of them. So you don't need to pool them. You also want to avoid long running actions, because let's say you have an operation that runs for a long time, right? It's going to be using lots of CPU. It's going to be utilizing a platform thread, and it's not going to be able to get moved away from the carrier thread, right? Because it's going to be running for a long time. So if you have lots of long-running actions like that, and you're still creating lots of virtual threads, you end up sort of monopolizing the platform threads. So this might be a situation where if you have long-running actions, you might actually just want to use normal threads, because you're not going to have new ones being created and then waiting, essentially. So keep that in mind as well. Also, you need to be careful with thread local variables. So thread local variables are very handy. They've been around for a long time, and it's basically just the ability to associate data with a thread, right? Which is really great if you're working in a per request model where you have an incoming request and you just want to store some data for that request. And the problem, though, is if you use it as a cache and you put mutable non-thread saved objects, it doesn't work out too well. And the reason is because, remember, with virtual threads, you can create lots of different virtual threads, right? So with normal threads, you're only creating a small number, so you can cache stuff or whatever, and it's not going to be an issue. But if you're caching data and you're creating hundreds or thousands of threads, virtual threads, that can be a problem. So scope values are the alternative to this. They allow you to do that sort of caching. If you have an app that's just using thread local for a very little bit of data and in a way that's not going to be broken by the way virtual threads work, you can still use it. It's not like you can't use it, but you just really shouldn't use it for caching and pooling. So you can use virtual threads manually just by using a new executor. So you use the virtual thread per task executor. And so it uses all the same APIs. It also uses the thread interface or class, I think. So you basically just have to use a different executor and you magically get virtual threads. That's the idea. It is really nice. You can also create them manually if you want to. So that you can do thread of virtual. So this creates a new unstarted virtual thread. Then you can just start a virtual thread by throwing in a runnable, and then you can also check to see if something is a virtual thread by is virtual. So those are new methods which have been added to the thread class. And one of the things I wanted to point out is that before I get to that, is that the I think one of the things we should all of us Java folks should understand is that the folks at Oracle, even if you're not a huge fan of Oracle the company, the Java team is a brilliant team, and they're very, very forward thinking, but they're also very methodical. And so we're now talking about this great new virtual threads feature. It's been out for about a year in production, right? But it also was released a year before that, right? But work has been going on for virtual threads for a long, long time. So we said Project Loom started in 2017, right? And that was several years ago. Since then, several different things have happened. The JVM internals have been reworked to support virtual threads across the board. This has been happening slowly over different releases. So the Thread API, of course, has been updated. Java Util Concurrent, Java Net, Java NIO channels, Java IO, all of these things have been updated basically so that they work properly. So, if there was something that was using a synchronized block and now uses a reentrant lock, there's other more low-level things about them that needed to be changed. Those have been changed as well. Also, they updated the debugging tools. So if you are debugging anything with virtual threads, there's full support for them across everything like stack traces and things like that as well. There's also been other JEPs along the way, which were sort of in preparation for this. So JEP 416, re-implement core reflection with method handles, and JDK 18 removed VM native reflection implementation, which is important for virtual threads. JEP 353 re-implement the legacy socket API in JDK 13, and JEP 373 re-implement the legacy datagram socket API in JDK 15. Replaced implementations of some of the core socket classes with implementations that work with virtual threads. And JEP 418 and JDK 18 define an SPI interface for hostname address lookup. And that allows third parties to have alternate internet address resolvers that don't pin threads. So another nice addition there. So I just wanted to make sure everyone's aware of all the groundwork that's gone into making this happen. So now that it's there, what about usage in our everyday life. So for those of us, if you're writing an application that's using networking or using that needs to be asynchronous out of the box, it's not necessarily a service. You can use the raw thread APIs, the executor service, etc. You're good to go, right? You can use virtual threads. If you're using something like Quarkus or Microprofile or Spring Boot or whatever, well, then things are a little bit different, right? You need to see if you actually have support by the actual version of the framework you're using and the libraries that are come along with it. So Apache Tomcat, which is used by default by Spring Boot and by lots of people for different applications, that's provided virtual thread support in 10.1.1. So 10.1.1 or higher, you have virtual thread support, basically just by turning on the virtual thread executor. So it's a very simple configuration option that you can add. Now, if you're using Tomcat with Spring Boot or something else, you should look at the actual way to do it through the framework you're using. But if you're using raw Tomcat, like let's say with a JSF app or a Servlet app or JAX-RS or something, this is a way you can turn it on. Eclipse Jetty, 10.0.12. Yeah, I thought I turned off my notifications. My bad. Let me change that. Okay. Eclipse Jetty 10.0.12 and 11.0.12 and higher also have virtual thread support, which you can turn on. It's a little bit more complicated, but you can do it. And basically by doing this, so when you create a thread pool, you can set virtual thread executors to the new virtual thread executors. Okay. So if you're using Jetty, you can do it that way. Also, you can do it on the command line as well. So again, if you're using a framework on top of that, do it using the framework's options. Netty does not currently have support, and this kind of makes sense because Netty's built from the ground up to be reactive. So whether or not they need support virtual threads, it's questionable. They do have an issue open for it, so if you're curious, you can go check that out and see sort of all the discussions. It's kind of interesting. It looks like they might actually add support eventually. So Undertow, which is used by Wildfly, I have seen no evidence of them supporting it. But it doesn't mean there isn't. There's just no publicly available information I've seen recently for Undertow. So those are all the sort of servlet container or web server APIs. For microservice frameworks, they support it as well. So Quarkus has very well-documented support. They say the performance is almost as good as Reactive. However, they do recommend using Quarkus REST and Quarkus Reactive extensions. And the reason they do this is because they have found cases where there are some issues with some of the third-party libraries with supporting virtual threads. And if you just use reactive stuff, then you don't have any issues. Everything just kind of works. So you can take that with a grain of salt. This is an example of actually Quarkus. So this is a normal Jakarta REST resource. It's a GET request, and they've added this special annotation called run on virtual thread. So they've got opt-in support, and you have to do it on an opt-in basis, which is good and bad. I kind of wish and maybe there isn't, that I just haven't seen it. I kind of wish there was like a global option that just say do it globally if you want to, or allowing you to do it individually. So by default, it'll not be running on a virtual thread, but you can add support with this annotation. And this is a normal method, but you see here we're doing get with async, right? So this is an asynchronous method that runs in the background. But whoops, sorry about that. I keep on pressing the wrong button here. Let me jump ahead. Okay. So, but they make it very easy to just say, I'm going to run on a virtual thread. So you can find lots of Quarkus examples here. And I'll make sure, I'm not sure how she does it, but I'll make sure you have a link to the slides. I'll show them at the end too, so you can grab these. Quarkus examples there. Helidon, which is Oracle's open source microservice framework, supports as well. What's interesting about Helidon is that they have actually replaced Netty completely. So what they did was they took a step back and they said, well, we know we're going to have virtual threads, right? And we're using Netty for all of our reactive stuff. But what if we just wrote a web server from scratch using virtual threads? And they did, and it's called Nema. And it has equal to or better performance, and it's a lot less code. Like they were really amazed with how much less code they had to write to do it. So yeah, so I see Martin there. Yes, I'm going to get to the libraries, Martin. Don't worry. So, anyways, so I think that's kind of really interesting that they've done that. So they've fully embraced it with the Helidon 4. So Micronaut 4 has support as well, which is handy. And Spring Boot prior to 3.2, you can do it manually by basically changing the executors that are being used. So you can see this is the application task executor being named. And we have a new task executor adapter, and you see this is that new virtual thread per task executor. I'm doing the same thing here. So you do it this way, and prior to 3.2. And 3.2 plus, you can just turn it on. And they also want you to use this keep alive variable too. And in Spring 3.2, they also reworked the internals. So it's really smart to upgrade if you can, if you want to use virtual threads. You have to be using Jetty or Tomcat. It doesn't work with Netty or Undertow. And one side effect of virtual threads is that they're daemon threads, or daemon threads, depending on how you want to say it. So this basically keeps the main thread alive. Otherwise, your Spring application will just quit eventually. So you have to do that. Okay, so that brings us to Jakarta EE. So what's the deal with that? So several of you are using Jakarta EE implementations like Open Liberty, Wildfly, et cetera, et cetera. And it turns out this is largely an implementation detail. And this is what I think is interesting about it, because if you think about it, there's two different levels, right? There is one, which is the request coming into your application. And that's usually what we think about. It's like, okay, I have a Jakarta REST API and or a microprofile GraphQL API, whatever. And that request, is it running on a virtual thread or a real thread? Okay, and that is going to depend largely on your application server and what they have supported. So the key thing is to look for whatever docs you see, if there's a way that you can control the executor that's used for the threads for your incoming requests. And last time I looked, I did not see any details for any of the main Jakarta E servers. I'm not sure. I'm not saying they're not available, but it's something to look into. Now, of course, if your app server is already using Tomcat or Jetty, you're good to go because you can configure them independently, right? I'd say if you want to have support for your incoming requests, take a look at your vendor. There is, however, in Jakarta EE11, which will be out soon this year, there is support for virtual threads for managed executors. So if you're using a Jakarta EE managed executor to do work in the background, you can use that. You can get a virtual thread version of that. And the way that works is by sensing the version of the JDK you're using, and I believe there's a global option as well. Jakarta E11 worked with JDK 17 and 21. So that's the deal with Jakarta EE. Now, as of course, everything is not perfect, right? We don't live in a perfect world yet. And there are some drawbacks. So, of course, we talked about pinning, right? Which basically means that you doing some operation that basically pins your virtual thread to a carrier thread. And the two cases are, of course, the synchronized blocks or native calls, right? Monopolization, which means running a long-running action on a virtual thread, because you can potentially monopolize a platform thread for a long period of time while your application is creating more and more virtual threads. Don't want to use local threads, or you don't want to use thread locals for caching. But the last one is sort of the main point here. So the third-party libraries may not have been updated to handle these concerns, right? Because we live in a very vast ecosystem of open source libraries that we all use. And the question is going to be, once you get past whether or not your framework supports it, you need to see the dependencies of your framework, and then also the dependencies of your application. Now, in some cases, the vendor may have done some work with their own dependencies, like Spring Boot 3.2, Spring Boot 3.2, Quarkus. They've done a lot of work to sort of determine which dependencies don't work and help you out, make your life easier. So in a lot of cases, you don't really have to worry as much about your framework's third-party dependencies, but you definitely have to worry about your own third-party dependencies, right? So a good example is Jackson. Jackson is the most popular JSON parser serializer out there, right? And they had some issues with virtual threads because they were using thread locals for caching. And they added, with the Quarkus folks, they added an SPI so that runtimes can use it for virtual threads. So now, if basically anything that uses Jackson, if they say they support virtual threads, they probably are using this SPI. But that had to happen first. And you'll have to make sure that that has been updated for the framework that you're using. OpenTelemetry and Spring Boot both have problems with using the traced pin threads parameter. And this turned out actually to be a bug in the JDK that was fixed in April 2024. So initially it showed up as a bug for each individual application, and it manifests itself in a few different ways. What's interesting is that if you look at the bug details, they specifically say that the trace pin threads feature was added for debugging initially, but eventually it's probably going to go away because it has some issues. So they've worked out, I guess, whatever the main issues people have had, but eventually they'll probably replace it with Java Flight Recorder or something else. So that's something to consider. But fortunately, this was fixed. But of course, this means that you have to have a version of JDK that's been updated since April 2024 not to run into this issue. So there are definitely some bumps. Another sort of key thing that you're going to need to worry about are database drivers, because of course, most of us talk databases, right? So Postgres has supported it since March 2023. Oracle, of course, has supported it since I think 2022, because of course they were very aware of what's going on there. MongoDB supported it since October of 2023. So a lot of this is just making sure you've updated to the latest version of your driver. SQL Server, not so much. So if you use SQL Server and you want to use virtual threads, you're kind of out of luck, unless you want to use reactive drivers for SQL Server. And of course, if you use other databases, you'll have to see what drivers they use. So that's something to keep in mind. We'll go back to this. So yeah, that's something to keep in mind. And so just make sure whatever libraries you're using that you kind of go through and say, okay, has been upgraded for virtual threads isn't an issue. And 99% of the time, if it is a valid issue, it'll be on our issue tracker if it's an open source library. And because most of what you'll find is, a big discussion about why they're not fixing it or fixes of it or whatever. So, and I will provide a link to the slides at the end. All right. So one of the things, even if you're not using Quarkus, you might want to read this blog post. This is actually a really good blog post. They've done a lot of research analysis about using virtual threads in Quarkus, and a lot of it is applicable beyond Quarkus. So check this out if you're curious about just sort of the ins and outs of it. And of course, remember you can use the JDK trace pin threads as well. All right, so that's pretty much it. I am going to put the link to the slides in the chat. Here are some other links. And if you have any last minute questions in the last 3 minutes, you can feel free to put them in there.
No. Awesome. Thank you so much for the excellent presentation today, Kito. And yeah, if there's anybody in the audience that does have any questions, please add them in the Ask a Questions tab or the chat as we wrap things up here. So I just wanted to take a couple of moments to address two little things. We are looking for more Jakarta Tech Talks for 2024. So I'm going to be providing the link to the form in the chat. So if you're interested in presenting a talk, please feel free to fill out the form. And then lastly, we have some very, very exciting news. Open Community Experience 2024. It's the Eclipse Foundation's flagship developer conference, also previously known as the flagship was EclipseCon, but EclipseCon is still within OCX. So join us for the ecosystem, for the global ecosystem that gathers on October 22nd to October 24th in Mainz, Germany. So I will also link the registration page for those that are interested in attending the event. So we hope to see you all there. And let's take a quick last minute look there. So we do have a question. Has nothing to do with the, okay, let me see here. Some from Victor. Based on what was presented today, would you say that it is always better to use a virtual thread instead of a normal thread? Jakarta
Yeah,
team, please do tech talk. Okay.
sorry about that. So I don't, in case you didn't see Victor's question in the chat, the response in the chat, I mean, you
Okay.
certainly, you would not always use virtual threads. It's like anything else, you need to see if there's a good, I mean, basically, I think if your libraries, if you don't have any issues with your third-party libraries and your framework supports it, you might as well try it out and see how well it works. See if it get an increased performance. There's no real drawback, but there's no reason you have to use it. It's really just if you want to try increasing your throughput of your application with minimal effort, that you would want to do it. And of course, you want to make sure your libraries actually support it and your framework supports it and things like that. So.
Okay. Beautiful. I think just a couple more comments that you had seen there, Kito.
Yes.
Perfect. Yeah, that is it. I don't see anything else. No questions in the Ask a Questions tab. So that is great. So I'll provide the links to both the Jakarta Tech Talk forum and also OCX. We hope everybody here that has joined us today is able to attend our amazing flagship event. Talk to you all soon. Take care.